In this mini lesson, we'll go over the methods that you should use when solving a system of equations, whether you should use the substitution or the elimination method. So, by this time, you should have learned both methods or all three methods because you have substitution, elimination, and of course graphing. But when you don't have a graph and you just only have the equations, you must use either substitution or elimination. So what method should you use if you're given a system of equations? So if the variables have coefficients of 1 or the variable is isolated, it is best to use the substitution method. So if the variable is isolated, that means that the variable is by itself, which really means that there's a 1 in front of that variable. So if the variable is isolated, mistake there. Isolated means that it's on the other side of the equal sign by itself. If it's isolated, then you should use the substitution. If it's a coefficient of 1, that means there is no number in front of it, then you would use substitution also. So in this case here's two examples of this. So if we look at the first example, y equals negative 7x plus 1, 5x plus 4y equals negative 19. Y is isolated. That variable is by itself on the other side of the equal sign, so it is isolated. So this we would use the substitution here because of the y. The variable y is isolated on the other side of the equal sign by itself. So we would definitely, I say definitely use the substitution method here because it will be much easier to do that. Of course, you can use the elimination, but that will be extra steps, so it wouldn't be as efficient. And on the second example for substitution, now neither one of the variables are isolated here, but we do have a coefficient of 1. And that coefficient of 1 is where we see this x here. That means there's a 1 in front of it. So coefficient is 1. So we would use substitution also here. I have a coefficient of 1. Coefficient of, my E is not coming out. Let's see. Let's try my E again. Coefficient of 1. Okay. Coefficient of 1. So yes, we will use substitution in this case also. Isolated variable, coefficient of 1. The best method is substitution. Okay, let's go down to elimination now. When equations are in standard form with coefficients greater than 1, it is best to use elimination. Okay? So when equations are in standard form, and that is what you see here, this is standard form. Now remember, there's three forms of your linear equations. You have standard form, you have the point slope form, and then you have the slope intercept form. But in this case, in standard form, which is, if we go back to the top, no, not back to the top, but to these equations here, both of these equations are in standard form. But the equations don't qualify because the coefficients are not all the coefficients are greater than 1. In this case, we have this x, which has a coefficient of 1, so we're not going to use the elimination. So when the equations are in standard form, ax plus by equals c with coefficients greater than 1, we use elimination. It'll be most efficient to use the elimination method at that point. And just let's look at an example of that. So here we go. We have the equations, the coefficients are greater than 1, and they're both in standard form. So we would use the elimination method here. Okay, if we want to just put another one up here, just for an example, we can say we can say here, let's see, without the board moving, we can say 5x plus 6y is equal to 15, and 3x minus 7y is equal to 12. So this would qualify for elimination method because the coefficients are greater than 1 and the equations are in standard form. So this is a mini lesson of what method to use when you are finding a solution to the system of equations. So the two methods in this case would be either the substitution or elimination.